We are still on the laws of logarithms. In the last clip, we looked at two laws of logarithms. The first one, we had that the logarithm of a number m to some base a, when added up to the logarithm of some other number to the same base, the logarithm of n, that the result is simply the product of the two of them expressed to the same base. And we had there also that the logarithm of m to base a, we subtract another logarithm from it, so n to base a, that this will simply be the logarithm of what? M divided by n to base a. Now the next law we are looking at states that if I have the logarithm of a number, say a, raised to some power x to whatever base, probably b, that this will be equal to x times the logarithm of that number a to base b. That is, we simply just do what? Fly that exponent to the back there. That is something like this. If I have, say, the logarithm of 10 raised to the power of 7, let's say this is to base 5, that is 7 being the exponent there, right, can simply run to the back, and we have it as 7 times the logarithm of 10 to base 5. Let's take some examples on this. Here we have three expressions: logarithm of 7 raised to the power 3, logarithm of 20 raised to the power 8 to base 7, and logarithm of the root of 15, cube root of 15 to some base. Right? The first and the third one were not, the base is not specified, it doesn't matter. So let's start with the first. We can see there, very straightforward. The logarithm of 7 raised to the power of 3. The rule simply says, please take the 3 and let it multiply the logarithm of 7 to whatever base it might be there. The same thing applicable to the second one, where we're told that what? That we should find the logarithm of what? Log 20 raised to the power of 8 to some base 7. We'll simply move our 8 to the back there to multiply, and we have it as 8 the log of 20 to base 7. Now the third one requires a little bit more simplification. Log of cube root of 15 to base 5. Cube root of 15 from our indices, the same thing as saying 15 raised to the power of 1 over 3 to base 5. And of course, what this law is saying is that our 1 over 3 can be moved to the back there, and we have it as 1 over 3 times the logarithm of 15 to base 5. Now look at another law. This law simply states that the logarithm of a number expressed to the same base, log of a number, let's call it a, where the base is the same thing as a number, is simply 1. Be it log 10 base 10, log 5 base 5, log 1000 base 1000, log y base y, as long as the number and the base are the same, that each of these will be equal to 1. Now we have to use this to simplify these three expressions. Of course, you can see this straight away. Log of 9 to base 9, following the rule, is simply 1. We'll work more on the second and the third and see how to apply that law in simplifying those expressions. The first one is a walkover. We don't have to bother ourselves with this. We all agree, following the rule, that log of 9 to base 9 is 1. No argument. The second one, We should have here that the log of what? Let's go through the process. 64 to base 4. How do I apply this law? I look at 64. Oh, 64 is 4 times 4 times 4. Okay. Then this will be the logarithm of 4 raised to the power of 3 to base 4. But the previous law we just studied told us that what? That this 3 can be moved to the back there. So we have 3 times the logarithm of 4 to base 4. Now here we have the logarithm of a number to the same base. And the rule says what? The rule there says it should be equals to 1. So this is like, say, 3 times 1. And that gives us 3. So logarithm of 64 to base 4 is what? Is 3. Lastly, for this law, we have to do what? Simplify this. Logarithm of 0.001 to base 10. Without wasting too much time, we know that 0.001 is as good as, say, logarithm of what? 1 all over 1000 to base 10. And of course, 1 over 1000 is as good as writing the logarithm of 1 all over 10 raised to the power 3 to base 10. And we know this is 10 raised to the power minus 3. And that rule, the previous one, said that the minus 3 reduces the exponent, can but move to the back. So that's how we have minus 3 log 10 base 10. Now this present law is saying that the logarithm of a number to the same base is 1. So this is log of 10 to base 10. That will be 1. So we have minus 3 times 1. And that's how we have our minus 3 there. So that's the 5th law we have seen so far. I think we have just one more to go. Yes. This law states that the logarithm of 1 to base a is equal to 0. I'm very sure, very smart ones here. You can see that this must have been deduced from a raised to the power 0 is equal to 1. The law of indices that says any number raised to the power of 0 is equal to 1. You can see that here. Converting this to exponential form, a raised to the power of 0 will be equal to 1. So it is very correct. If this is true, then this is also true. Practice a few things there. Yeah, we have here logarithm of 1 to base 7 is 0. Logarithm of 1 to whatever at all, it's 0. As far as it is log 1 to any base at all, it must give us 0. So far, those are all the laws we have considered. The first one says that the logarithm of m plus the logarithm of n is equal to the logarithm of m plus n, all to the same base. The logarithm of m minus the logarithm of n is simply the logarithm of what? M divided by n to the same base. The third one says we have the logarithm of a number raised to some exponent, that the exponents can simply go to the back, and we have it as x log a, that's x multiplying log a. And here we are told that the logarithm of a number to the same base is equal to 1. So log 7 base 7, log 10 base 10, log 5 base 5, all will always be what? 1. And finally we had that the logarithm of 1 to any base at all is equal to 0. So we have seen all the laws. In the next video clip, we are going to take some composite logarithm expressions where we'll try to apply 2, 3, or 4 of these laws to resolve those problems.